Okay, amigos. We are filming quiz number one review. This quiz is the one that's going to be on this Friday. So let's see. Today is the 19th, so that means that quiz is going to be on the 23rd. So I've got a couple of things that we're going to do, and we've reviewed these in class, or we're going to review them in class. But I thought I'd make a video for you just in case you're confused on any of them. First things first, though, I'd like you to take a look. If you go to my website, let's see, my website here. Down here, there's the UTIPS login. If you just click on that, you will end up going to a site like this, and this is where you can find all the UTIPS tests. 1 through 5 are what you need to do for your credit this term, and then 6 through 8 are extra credit, and then this one down here is just a full CRT practice, which is kind of fun if you want to do that. But right here, there's a pre-algebra reference sheet, and if you open that up right here, you'll see a sheet with a lot of different math data kind of things on there. You get this reference sheet when you take the pre-algebra CRT. So I kind of want you to get comfortable with it and understand what we're doing with it. And the main thing that I want to focus on is this piece right in the very middle, the properties. They've spelled them out for you pretty well, but you're going to need to know how to do those. We're going to need to know how to do them for the quiz. And so what I'd like you to do is go ahead and look at those and take the test 1 to practice. But really they're not too hard. Everything seems to match up pretty well with them. You'll end up with a question like this. You'll have something like 7 plus 4 equals 4 plus 7, and then you need to match it up to which identity or which property that goes with. So if you look at your list here, you can see right here in the middle I've got one that switches the numbers, and that would be the commutative property of addition. So you need to kind of go through and figure those out. I will post on the website the UTIPS website right down here. I will put a spot that has just properties questions, and you could take and practice some of those. Once again, that would just be practice for you, not for credit. But obviously, if you gain credit there, then you'll probably gain credit on your quiz. All right, the next thing that we need to cover for this quiz is absolute value. Absolute value can be kind of tricky, and it's not something we spend a whole lot of time on. What it means is this: when you have these two vertical lines and a number in the middle, no matter what it is, it's going to come out positive. So if it was -9, it would come out positive 9. If it was positive 8, it comes out positive 8. So no matter what, it comes out positive. And a lot of times they use it with number lines. And so they'll say something like this. So from 0 to -3 is 3 units. And what math principle could you use to show that? And you would say, okay, -3, and the absolute value of that is 3. And all that means is you jumped 1, 2, 3 times to get there. And they use this absolute value just to show movement. Even though it's negative movement on the number line, that doesn't mean that you have to say, hey, you move -3 times. You can just say, hey, we move 3 times. And it doesn't matter in which direction. Okay, so that's the idea behind absolute value. Another piece to it is this. Let's say we've got something like this: -2, absolute value of -2 plus the absolute value of -3. When you take the absolute values, it's really just 2 plus 3, so that's not too bad. But then they like to try and get tricky and put negatives on the outside of your absolute values. Okay, and so when you do that, the absolute value of 6 is 6, but then you have to apply your negative sign. So be careful on those. They'll try and trick you. And then they really want to trick you. They'll do something like this: negative, absolute value, negative, parenthesis, -2, absolute value. Okay, so we do what's inside the absolute value first. So a negative and a negative makes a positive. So I really have a positive 2 right there. And then I apply that negative on the outside of the absolute value, like that. So anyway, a little tricky. We are going to cover that in class. So be aware of those. That is 1-3 of your textbook if you want to go check that out. Okay, the other things that we're going to do on the quiz, you're going to need to work with scientific notation. Most of you should be pretty comfortable with that. You do that in your science classes a lot. So what you have, let's say you have a number like 327, so 327,000, okay? And they want you to write that in scientific notation. What you do is you put your decimal point on there and you count how many times you had to move it to get one whole number out in front. So not there, but right there. We want this one number to be out in front, that's it. And then everything else should be behind in a decimal. So I had to move it 1, 2, 3, 4, 5 times. So I have 3.27 times 10 to the 5th. So that is how you do scientific notation. Now it gets a little trickier when they give you decimals, something like that. Once again, we want to try and get one whole number out in front. So I move it 3 times so I can get this 2 out in front. So that gives me 2.1 times 10, and I moved it 1, 2, 3 times. Now, what's the difference between these two? Well, this one right here, I made the number smaller, okay? So this should be a positive number right here. This one I made it bigger, right? I moved it from a small decimal to a whole number out front. So this needs to be a negative 3 right here, okay? So when you're going from a decimal to a whole number, make sure you write that it's a negative. When you're going from a big, huge number, in which you can't see, a big, huge number, to a decimal, then we write it as a whole number, or as a positive number. Okay. Next thing, and we've got, this one was a pass-off sheet, so we should be pretty familiar with this. This is just dealing with your powers. So when we have the same base, x and x, it could be a 2, it could be a 9, it doesn't really matter. So let's do one with like 3's. So when you do this and we're multiplying them, we are just going to add these together. So that would be x to the 6th. And remember we talked about it, it's x times x times x times x times x times x. And how many x's does that give you? It gives you 6. Same deal here. It's 3 times 3 times 3 times 3 times 3 times 3. I got a couple 3's there and I got 4 3's here. And so that really gives me 3 to the 6th power. Now what you can't do is when you have like 2 to the 3rd times 3 to the 4th, your bases aren't the same on this, so you can't do it this way. You actually have to come up with a numeric answer. So you need to go 2 times 2 times 2 times 3 times 3 times 3 times 3. Anyway, so this only works when your bases are the same. The other two that we had were division. So something like, let's make that a bigger number on top. Something like this. And when we had division, you know, we just subtract. And we also had something like this where we raise to a power. And when we're in this case, we multiply. So that would be 5 to the 6th. Okay? Alright, and once again, you could go through and work these out if you were confused. You have 5 times 5 times 5 times 5 times 5 times 5, 6 of them. And then 5 times 5. And we know 5 over 5 is 1, so there's a big one there, and another big one. That leaves me with, you guessed it, 4 5s. Same deal here. I've got 5 times 5, but I've got it 3 times. 5 times 5, and 5 times 5. And how many 5s did they give me? 6 of them, just like that. Okay, last thing, and then we'll get you off here, is the Pythagorean theorem. We've been working on this off and on all year. It only works on right-handed or right-angled triangles. And remember, this is the whole A, B, C, where A and B don't really matter, but C is always the hypotenuse, the slanty side across from the square. and we do this whole a squared plus b squared equals c squared. Okay, and so in a triangle where we know a and b, our lives are pretty easy. So let's go with a basic 3, 4. We square 3, we square 4, and we square c. 3 squared is 9. 4 squared, 4 times 4 is 16, equals c squared. I add these together and I get 25 equals c squared. And I don't want c squared, right? I want what c is. So to unsquare something, I take the square root. Square root of c squared is just c, and the square root of 25 is 5. So that was easy because we just could add those together. It gets a little trickier when we have c and a and b. So when that's the case, let's go with 3 and 5 and b. So we'll say we don't know that one. So we would go 3 squared, because that's a, plus b squared, and then c squared, which is 5. And so I'd get 9 plus b squared equals 25. And then we need to get b by itself. To do that, I need to get rid of the 9. So I subtract. B squared equals 16. And I don't want b squared, I want b. So I take the square root and the square root. B equals 4. So in this one, where we have c, we're going to have to end up subtracting in order to make that work. Alright, that is it. As always, I'm here on Tuesdays and Thursday mornings to help. We will be reviewing this all week long. The quiz should be about 10 questions long, not too bad. Or if it's not 10 questions long, it's at least 10 points worth. Alright, have a good one.